So we're asked to compare two methods of integrating this expression. The usual method is integrating by parts. So if we decide to integrate the e to the ax and differentiate the sign, then that gives us e to the ax over a sine bx minus e to the ax, and then I differentiate the sine bx, so that gives me a b out here, and I get cos bx dx. Okay, then I'll just keep this. Okay, I'll just write sine and short for sine bx minus b over a, and then I do the same thing with this integral. So I'm going to differentiate the e to the ax, and I'll write cos instead of cos bx. And this time when I differentiate cos, of course, I get a plus sign, so I'll end up with b over a e to the ax sine bx dx. Okay. So this thing here is the integral I want. So I'll just call this thing, just notice that that's equal to I. So just expand the brackets. And then move this onto that side, and I get 1 plus b squared over a squared I. I may as well, to save time, I may as well multiply top and both sides by a squared, so I'll do that. So multiplying both sides by a squared, I'll get a, I'll take out a factor of e to the ax. I'll get a times sine minus b times cos. So the final answer is the integral I want is 1 over a squared plus b squared e to the ax times a sine bx minus b cos bx. So the alternative way is to realize that, of course, sine bx is the imaginary part of e to the I bx. So I can rewrite this as the imaginary part of e to the a plus I b x dx, which is much easier to integrate. So I can do that in one step and get e to the then all I need to do is find the imaginary part, which I do simply by multiplying top and bottom by a minus ib. So that will give me the modulus on the bottom. So a squared plus b squared on the bottom. On the top, I can take out the factor of e to the ax. That's real, I'm assuming. And that leaves me with cos bx plus sine bx, times a minus ib. So then I can write the rest in one go, because I just pick out the result of this multiplication, which gives me the things with I in. So I end up with e to the ax. So what's going to give me I? Well, I'll get, sorry, I missed out the I here. I'll get a plus. So I'll get an I from the A times sine bx, and I'll get a minus I from the B times cos bx, and then that's all over a squared plus b squared. So I think it's a little bit quicker.